name is Scott Williams with Carrier Great Lakes. In this video, we're going to go over the installation of our multi-family 24-volt air handler with our ductless outdoor unit using our 24-volt interface kit. Before we begin installing the equipment, I'm going to go through the steps that are required for the proper installation of this hybrid combination. The first step that's required is to mount the indoor and outdoor unit in their installation location, following the clearances required in the installation manual. The next step, and one of the most important, is to remove the metering device from the indoor unit, whether it's a TXV or piston. This may be easier to do at your shop as opposed to on the job or once the equipment's already mounted, but that's all going to be dependent on the specific job. Once you've removed the expansion valve, the third step is to install the piping adapter kit that's going to connect where the TXV used to be connected. If you have a unit that has a copper coil, the piping adapter kit is not required, as you'll simply cut and braze the connection at the indoor unit. The next step is to run the line set from indoor to outdoor using the size required for the outdoor unit. A bushing or reducer may be required for the indoor unit connection depending on the combination of units that you have. The next step, and this is another one that can be done beforehand at your shop or wherever's easiest, is to remove the 24-volt transformer from the 24-volt interface kit, as the combination will use the 24-volt power from the indoor fan coil to power the thermostat and low voltage connections. The next step is to mount the 24-volt interface kit. The interface kit can be mounted indoors or outdoors, and again is going to be dependent on the specific job where it's easiest and most logical to mount it. The next step is to run the power and communication wiring L1, L2, and S from the outdoor unit to the 24-volt interface connection. The next step is to connect C, R, Y, W, and G from the thermostat to the 24-volt interface. After that's complete, you want to connect the fan signal wiring to the output G1 on the 24-volt interface and run that directly to the fan coil G connection. Next, you'll need to select the proper indoor fan speed for the size unit that you have using the charts provided in the installation manual. After that, you'll install the return air temperature sensor on the inlet side of the fan coil. There is an extension cable if required if the interface kit is mounted outside. Next, you want to connect the line voltage for the indoor and outdoor unit, which uses a separate power supply. One note about the G1 output on the 24-volt interface is that during the defrost cycle on the outdoor unit, the outputs G1, G2, and G3 on the 24-volt interface will not provide output to the indoor fan during the defrost cycle plus 30 seconds. That's why we're using the G1 output going directly to the fan coil from the interface kit as opposed to using the G signal from the thermostat so that we can turn the fan off when the unit goes into defrost to prevent blowing cold air on the occupants. Here's a diagram that shows the steps required to remove the transformer from the 24-volt interface kit. Here's a picture of removing the metering device from a copper coil indoor unit. And this example shows removing the metering device from an aluminum coil indoor unit. One note is that the adapter is required that connects to the distributor on the aluminum coil when you have an aluminum coil indoor unit. This is the part number and description of the piping adapter kit. It also comes with instructions on how much torque to tighten it when you install it on the unit.
All right, so when you're removing this insulation gum,
you want to try and cut as carefully as possible and slowly peel it back. You don't want to chance gouging the suction line or cutting into the TXV sensing bulb. Alright, so now after we got the insulation off of it, we're going to remove our TXV sensing bulb from the suction line. It shouldn't make a big difference, but try to get any excess that you have on the line if you can. So now we're going to remove the TXV equalizer line. You want to cut and pinch it. That way it's easy to brace shut. Once that's complete, now we're going to move on to removing the insulation from the liquid line so that we can then remove the expansion valve. So now that our equalizer line is cut and pinched, now we're going to work on removing the insulation on our liquid line.
Ready.
All right, so now that we have the insulation off and everything disconnected, we're ready to remove our TXV. It's important that you use a backup wrench when doing this to make sure that you don't twist the distributor that the TXV is connected to. So now our TXV sensing bulb and equalizer line are removed from the system. So what happened when I removed the TXV from the distributor was the white Teflon seal that seals what's called the shatlet fitting stayed inside of the distributor. So what you want to do is remove that seal before installing the pipe adapter. The pipe adapter comes with a brand new seal, which will give you no chances of having a leak. So the section of pipe that we removed from inside the unit that's brazed to the TXV is specially bent to make it out of the unit on the right angle. So you'll want to reuse that pipe after you remove it. So what you want to do is take the adapter fitting and mark your cut and cut this off there to remove the expansion valve. Now you can reuse that pipe and it's going to exit the unit at the same spot. So now we mark where we want to cut the pipe at. Now we're going to cut it off the TXV. My suggestion is that you braze the adapter fitting to the piece of pipe that you cut off outside of the unit. It'll give you much more room. Now when you're doing that, you want to be sure to remove the Teflon seal on the adapter fitting before you braze it. All right, so now that we finished brazing our adapter fitting to the original piece of pipe that we removed from the expansion valve, now we're going to reinstall it in the unit. You want to make sure that you get your Teflon ring on there because that's what actually creates the seal when it's connected to the distributor nozzle. And you want to push it in there, and you want to make sure that it's flush all the way around and everything lines up. And now you can check your fit where it's going to exit the unit. Make sure everything's lined up. Now you want to begin to tighten the nut. Now instructions come in the bag for tightening the nut to the distributor. It tells you to tighten it to hand tight and then add 1/2 of a turn with the wrench. So it's a little bit tight in here. We might have to do 2/4 turns. little bit more, now we're tight. Now that we have our liquid line connected, now we need to brace shut our TXV equalizer line in the suction line. It's important whenever you're doing any brazing in the system that you have nitrogen flowing, especially with the ductless combination, because the ductless outdoor unit has very fine screens at the expansion valve. After you remove the expansion valve, it's important that you replace the insulation on the lines inside the cabinet so that you don't have any condensation that drips where it shouldn't be. Depending on the combination of indoor and outdoor units that you have, you may need to get reducers for the line set. You always run the line set in the size that it connects to the outdoor unit. Now that we have our line set run, we're ready to do one of the most important steps in the installation, and that's making the flare connections at the outdoor unit. The first step to making an effective flare is to make sure that when you cut the pipe that you cut it square and as clean as possible. That'll give you the best chance to have a leak-free flare the first time. After you make your cut, it's important to clean out the inside of the pipe and make sure that it's facing downwards when you do so that you don't leave any copper shavings in the pipe. Now that those steps are complete, there's multiple types of flaring tools that you can use. This one is called an orbital flaring tool, and it's one of the most common. We also have a different kind, which is much faster, and I'm a big fan of it myself, and that's the flaring spin set. One reason I like it is how fast you can make a flare. Another reason is that you can never go past the stop on it. And another reason is because it's spinning so fast, it actually cleans off the inside of the pipe if there's any burrs left over. So we're gonna use both of those options today. So we'll start with our orbital flaring tool. So we're gonna get it set on the pipe. When you're attaching it to the pipe, the block to the pipe, you wanna see just a touch past the top of the block. And then we have our little slide here to make sure on this particular yellow jacket tool. Once we know our depth is right, now we're going to tighten our tool down. One reason I like this particular yellow jacket orbital flaring tool that we carry at Carrier Great Lakes is that you can use a drill with it as well if you choose. There's a 1/4 inch connection that goes in there if you choose to use that option. Otherwise, you can use the handle. Another reason that I like this tool is that it has a clutch, so you can't put too much pressure on the flare, which can cause it to leak. So now that we have everything tightened down, we're ready to make our flare. Now see how the clutch just released there? Now I know that I put enough pressure on it. Now you want to back it off. Now that I've made my flare, I find part of it that I don't like. Every tubing cutter has a notch in it so that you can cut the flare off without taking extra pipe length that you may not have to work with. All right, so now that our pipe is cut and we've cleaned out the inside after cutting it, you want to make sure that you put your flare nut on. I prefer to use the ones that are on the unit just from experience and what I've heard from other contractors. They seem to have more success with the flare nut that came with the unit as well, as opposed to one that's on the line set. So now, when we're putting our flaring tool on here, we want to align the end of the pipe just past the top of the flaring block. That'll give you the correct depth when you're making your flare. All right, to make our other flare, we're gonna use a flaring spin set. So you wanna make sure that you have your drill set to full torque and the maximum RPMs if it's adjustable. Now, it's important that you wear gloves because the copper gets extremely hot, or some other form of holding the pipe. The keys to using this tool are to keep the drill perfectly straight with even pressure until you hit the stop, and then remove it while it's still spinning. All right, now we're ready to torque down our flares to the service valves. One thing that's extremely important is that you use a proper torque wrench when you're making these connections. When you're ready to make your connection, use a little bit of oil, preferably refrigerant oil, and put it around the cone of the flare. That'll prevent it from twisting the pipe as you get to your maximum torque. All right, so for this example, we have the Hillmore digital flaring tool. I've already set my maximum torque per the specification in the manual. One nice thing about this tool is that you can save in the memory numerous torque settings depending on the size of pipe that you're connecting. Another nice part is that it's adjustable, so you don't have a bunch of different parts that you have to change out. One other recommendation is that you use something to back up the service valve because you're putting a lot of pressure on it. Even though it's screwed in, it's still good practice. So you'll see as you start approaching your maximum torque that you have set, the wrench will start alerting you and the lights will actually increase until you reach the red. So now we have that properly torqued. When a 24-volt interface kit is paired with a conventional fan coil, we need to remove the transformer that comes inside the interface kit. The 24 volts will be supplied from the transformer in the air handler. So we need to pull our wires off of CN16 and CN17, which is 24 volts from the transformer. And then we need to pull our high voltage wires off of CN2 and CN1. Then you want to unscrew the transformer and remove it from the interface kit. If you aren't going to be using an electric heater kit with this installation, these two wires that'll come mounted right here in the unit will be your high voltage power connection. So you plug it in to this plug here, and then you'll make your line voltage connections inside the unit. Now that we have our air handler mounted, we're going to install the electric heater. When you're using the electric heater, you can take these wires, which would be your power connections without the electric heater, and remove them and discard them. When you're installing the electric heater, you want to make sure that you follow the airflow direction that's labeled on the electric heater. There's two tabs in the back that you have to line it up with, which secures it on the back side. Now we're gonna mount our circuit breaker where our line voltage is gonna enter the unit. You'll only have this on the unit if you have an accessory electric heater. Now that we have those mounted, we now want to make our power connection to the air handler. All right, now we're going to hook up our interconnecting high voltage communication wire between the ductless outdoor unit and the 24 volt interface kit. This is not necessary so that the 24 volt interface kit can control the speed and refrigerant flow of the ductless unit outside and also tell it what mode to operate in. It's important that we use 14 gauge stranded wire when hooking this up to avoid any possible communication issues. When you're hooking up L1, L2, and S, make note of which color goes where. If L1 and L2 get flip-flopped, then you'll have a communication error. You also want to ensure that you don't put line voltage on either of the S terminals. So for this example, we use black for L1, red for L2, and white for S. Now we're going to go to our interface kit and tighten those connections down. Black is L1, red is L2, and white is S. And we'll also tighten down our ground. Now we're going to hook up our low voltage control wiring. So we have two sets of thermostat wires. I'd recommend using a 6 or 8 wire so that you have extra. We're getting our 24 volt power to the interface kit and to our thermostat from the transformer and the air handler. So we have both of the R wires and both of the common wires tied together underneath these terminals. One set comes from the air handler and the other set goes to the thermostat. Then we also have our G1, which goes to the air handler. So the interface kit controls the fan operation in heating, cooling, and when the thermostat gives a call for fan. So G1 will be energized on a call for heating, cooling, and it will de-energize in defrost mode. So we hook our G wire from the air handler to G1. Then we have our Y, W, and G, which go to the thermostat. So those are our commands for what mode we want to operate. The low voltage connections at our air handler use 4 wires. We have our R, we have our common, we have our G, and we have our W, which is for auxiliary heat. So the reason that we have 2 thermostat wires over here is W comes directly from the thermostat and doesn't go through the 24 volt interface kit. So when the thermostat calls for second stage heat or auxiliary heat, it'll energize the W terminal independent of the outdoor unit or the 24 volt interface kit, which will energize the fan and the electric heater in the unit. Our other 3 wires go directly to the 24 volt interface kit. So we have our R, our G, and our common. When we're hooking up the wires at our thermostat, we have 2 sets of wires. One of the sets of wires only uses 1 wire, and that's W2, which goes directly to the air handler to energize electric heat. Our other set of wires is our W, R, C, G, and Y. And those go to the interface kit to give the interface kit the command to either run heating or cooling, or fan only. The last step required in this installation when hooking up the 24 volt interface kit is to install the return air thermistor. So the interface kit has a pigtail that comes off it, and you plug in your thermistor to that pigtail. If your interface kit is further away, there's also an extension wire that you can use to to extend the length. The reason we need this return air thermistor in this setup is so that the interface kit knows what the space temperature is by using the return air temperature to sense that. This is necessary to maintain variable speed operation with the outdoor unit. So at the end of every call, the interface kit references what the return air temperature was when the thermostat is no longer calling for heating or cooling, and uses that temperature to control to for the next call for heating or cooling. By doing that, it knows what your set point is based on that return air temperature when the thermostat's no longer calling for heating or cooling. We've evacuated our system and we've held it below 500 microns for a half an hour. Now we're ready to start it up. Now that we have our service valves fully open and backseated, it's important to note that when you're putting the caps on them, that you tighten them down securely, as none of these service valves are meant to be leak-free. All right, now that we have everything else installed and complete, before we power the system up, we need to properly set the dip switches on the 24-volt interface kit so that the system will operate properly with the combination that we have. So we need to turn to the page in the manual that came with the 24-volt interface kit that shows the dip switch settings, and we'll go through and set each one. So SW1-1 by default is off. We're going to turn that on. So that one turns the display on. SW1-2 needs to be off. That's important in this scenario with the hybrid combination because we don't have a communicating ductless indoor unit. So we'll make sure that SW1-2 is off. Dip switch 2-1 should be off because we have a heat pump. Dip switch 2-2 should also be off. This will allow the indoor fan to stop when the unit is in defrost mode or the coil is too cold and heating. 3-1 should be off. That's not used. It's used for future applications. Now SW3-2 is the time, either 1 hour or 3 hours, at what point the unit will speed up to quickly meet the demand if it hasn't met it yet. I recommend turning that one to on to set it for 1 hour in case it's running for a long period and not meeting the demand. Then SW4-1 and 4-2 will also remain off as they're going to be used in future applications. A couple notes when installing the thermostat and configuring it with this setup is many different types of thermostats can be used, and generally that depends on the individual job. You want to make sure that you set it as a conventional system with 1 stage of cooling and 2 stages of heat. Some thermostats give you the ability to control when second stage heat comes on, so you can also set that according to the needs of the space. When you're starting the system up, to verify that your 24-volt interface is calling for the correct mode based on what the thermostat is calling for, when you're calling for cooling, you'll see a 0-1. When there's a call for heat, you'll see a 0-2. And then when there's a call for fan only, you'll see a 0-3. I want to conclude the video by going over the wiring that's required in this installation. So we'll start with the fan coil. The fan coil is going to have 4 connections on it: R, G, W, and C. Our R is going to go to our thermostat R and also go to R on the 24-volt interface. The same is true for common. This is going to provide power to the 24-volt interface and the thermostat. Our G is going to run from our 24-volt thermostat to G on the interface kit, so that if the homeowner wants to turn the fan on for circulation, when they do that, the interface kit will still have control of the fan. And that way, when the unit's in defrost, it'll turn the fan off so as not to blow cold air on the occupants. The other G wire goes directly from the 24-volt interface kit G1 up to the fan coil. Our thermostat is going to be set up conventionally, so we're going to use Y/Y1 on the thermostat and run that to Y on our interface kit. We're going to use W and go to W on our interface kit for heat pump heating. If your installation includes auxiliary heat, then you're going to use W2 on the thermostat, which is going to energize W1 on the fan coil, which will energize your electric heater as well. Our high voltage wiring from the ductless outdoor unit to the 24-volt interface kit, we use L1, L2, S, and ground, and it'll go to the connection that says indoor unit on the 24-volt interface kit. The diagram also shows where you have to connect to CN5 on the 24-volt interface kit, the thermistor that's going to sense the return air temperature. Without this being installed, the system will not operate.